Welcome guys. In this video we are going to continue with the topic of acids in chemistry. We are going to focus on naming and also how to deal with subchemical properties of acids. So let's begin with naming of acids. So there are some rules that you should at least follow for you to name a particular acid. Now, the name of an acid is based on the name of the negative ion present in that acid. For example, we first have to look at in a case where you are dealing with a monatomic ion. Monatomic ion is where the ion is just single, an ion that is made up of one atom only. So for this one, whenever this one is ending in IDE, we are going to replace with ic. Then after that, we look at the polyatomic ion. Polyatomic ion, we are looking at an ion made up of one or two atoms. For example, if this ion is ending with ATE, we are going to add IC. What of an ion ending with ITE, we are going to add as. So these are some of the basics that we are going to use whenever we are trying to come up with the name of an acid. So now let's look at the first example. So the first example, we have this HCl. Now if you look at this acid, the negative ion that we have is the chloride ion. So we said whenever you are dealing with a monatomic ion ending with IDE, you need to get rid of the IDE, then you replace with the ic. Now, before you do this, the first part that you need to do, as long as it is a monatomic ion, you need to write the word hydro. So hydro, then we are going to get this part, hydro, chlor, then we add the ICA. So the name of this acid is hydrochloric acid. Number 2, let's look at we are dealing with this one. So the first part is identify the ion. So the ion is iodide. So we are going to remove the IDE, we replace with ic. So the name is hydroiodic. Then away from there, let's look at where we can look at a polyatomic ion. So in case if you don't know what a polyatomic ion, I have a video based on the naming of this polyatomic ion and also some of the examples. So the ion that is here is nitrate. So we said whenever the ion is ending with "-ate", you replace with ic. So the acid is nitric acid. So for polyatomic ion, you don't have to begin with the prefix of hydro. So you just have to get rid of ATE, then you replace with the ic. What of this one? So the polyatomic ion is this one, SO4, which is known as a sulfate. So since it's ending with ATE, I'm going to write the name sulfur, then I add ICE. So this becomes sulfuric acid. Right, let's try this one. So NHO2. So the NO2, this one is known as the nitrite. So what are we supposed to do if it is ending with nitrite? So you remove ite, then you replace with the OUS, as. So the acid now becomes nitrous acid. Right. So these are what we call some of the rules that you can use if you're trying to come up with an acid. So as long as you understand it, it can be applied to almost all the names of acids that we have. Then I have a mnemonic that you can be using to name. So the first one, I will say myrite. So myrite has hydraulics, which simply means that whenever the negative ion is ending with IDE, I'm going to replace with ic. Right, then the second one, we'll look at I ate something ic, which also simply means that whenever the ion is ending with ATE, I'm going to replace with ic. Then the third point, we have Sprite is delicious. So whenever the polyatomic ion is ending with ite, then you place with s. So that is what we can use whenever we are trying to come up with a name. Now, since we have some ideas on how to name acids, now let's move on to chemical properties of acids. Right, so it should be chemical properties of acids. So the first one, the first chemical property that we are going to look at is, and before we look at that, if you look at the chemical properties, we are looking at the behavior of acids during chemical reactions. So the first one, we'll look at acid can react with pure metal, as long as it's a pure metal, to form salt and hydrogen. So that is the first property that we are going to look at. So we have acid plus metal is equal to salt plus hydrogen. Now, the properties of something are very important because these properties can be used whenever you are trying to construct chemical equations. So you need to make sure you master these. For example, if I have an acid of hydrochloric acid reacting with calcium, which is a metal, right? So the first one, we need to have a salt. Now, how do you name a salt? Remember, a salt is an ionic compound. So the name of an ionic compound begins with a metal. So you don't have to change anything with the metal. So the metal will come just the way it is, so calcium. Then from the hydrochloric acid, we are going to get chloric. Now we remove the ic, we now replace back IDE. So this becomes calcium chloride plus the hydrogen gas. Now let's convert this one into chemical equations. So the chemical formula for hydrochloric acid is HCl. So don't forget the state is aqueous plus calcium is Ca. Solid. Then when writing the chemical formula for salt, you need to now look at the valences. So calcium has a valence of 2. Then chloride, which is chlorine, has a valence of 1. So if we interchange, the chemical formula is CaCl2. So which means that one atom of calcium needs 2 atoms of chlorides so that they neutralize each other. So we're going to have CaCl2 aqueous plus hydrogen. So remember, the hydrogen is always a diatomic gas. So you need to remember you put a 2 here. Then we just have to balance. Now for us to balance, let's check if the number of atoms for hydrogen, yes, chlorine and calcium on the reactant equals with the atoms of those on the product side. So hydrogen we have a 1 here, so it means we have 1, then here 2. So hydrogen is not balanced. Cl, there is 1, then Cl here, we can see we have a 2. Then what else? Calcium 1, even here calcium 1. So we only have to balance the atoms of hydrogen and chlorine. So if you look at the lowest number is 2. I mean the lowest number is 1, then the highest number is 2. So how can we balance this one? We have to divide this into 2. So we say 2 divided by 1 is equal to 2, which simply means that we need to put 2 in front of HCl. Now remember, this 2 is affecting hydrogen and chlorine. So if we now look at this carefully, it simply means that this 2 times 1, we have 2 atoms of hydrogen, then times 2, we have 2 atoms of chloride. So our equation is now balanced. Then the other way in which you can view this, as HCl plus another HCl because of 2. So we are looking at this plus this. That's what this number 2 denotes. So that is our first chemical property. Then the second chemical property, we'll look at the reaction of acids with metal oxide. So acid plus metal oxide. So metal oxide is just a compound in which the negative ion is the oxide, which is the oxygen. So here we are going to have salt plus water. So for example, we can look at our acid. Let's use the nitric this time. Plus the metal, we can just use lithium oxide. So the salt, we said begin with a metal, so our salt is lithium. Then from the nitric, we need to remove ic, we replace back it, so this becomes lithium nitrate plus water. Now let's look at the chemical formula, the chemical equation. So the chemical formula for nitric acid is HNO3 aqueous plus lithium has Li with a valence of 1, then the oxygen has 2. So if we interchange, we are going to have Li2. Okay, so we have solid. Then our lithium nitrate. So nitrate NO3 has a valence of 1. Lithium has also the valence of 1. So in this case, we are going to have a 1-to-1 ratio. So just say lithium nitrate aqueous plus H2O liquid. We just have to check if our equation is now balanced. Then if not, we need to do some balancing. Now, let's begin with the hydrogen. So hydrogen, there is only 1. Here we have 2. Next one is nitrogen. There is only 1. Here there is only 1. Right? Oxygen, we have 3 plus 1, which is 4. So 4 on the reactant side. Then here we have 3 plus 1, which is also 4. Then what else? Lithium Li, we have 2. Then here we have 1. So now how can we balance this equation? So let's begin by balancing the lithium, which is a metal. So to balance lithium, we are just going to put 2 in front of lithium nitrate, so that we have 2 atoms of lithium. So it's lithium times 2, giving us 2. Now if you look at 2 times 3 is 6, plus here we have now 7 atoms of oxygen. So where else are we supposed to put the number? So we're going to put the number here 2, so that if we multiply 2 times 1, we still have 2. 2 times 1 for nitrogen, we have now nitrogen is balanced. Also here is balanced. Then what of oxygen? 2 times 3, 6, plus 1, 7. So oxygen, we have 7 atoms. Even here we have 7 atoms. Then our equation is now balanced, because 2 times 1 is 2. So we have our balanced chemical equation. Right, we move on to the third one. So the third one, we are looking at the reaction of acids with metal hydroxide, which is a base. So say acids plus metal hydroxide So a metal hydroxide is a base. So the products are salt and water. Right, for example, we are going to use the potassium hydroxide. Let's look at first the acid. So the acid that we are going to use is hydrochloric acid. Plus potassium hydroxide. Then the name of the salt, you begin by writing the metal, potassium. Then from the hydrochloric, we get chloride. So our salt is potassium chloride plus water. Now, chemical equation, hydrochloric acid has HCl aqueous, plus potassium has the chemical symbol K, hydroxide OH. Remember, potassium has a valence of 1, hydroxide also has a valence of 1, so this is a 1-to-1 aqueous. So we're going to have potassium with a valence of 1, chloride with a valence of 1. So in this case, you can just ignore aqueous plus H2O. Now, is this equation balanced? Let's check. So we are going to begin with hydrogen. So hydrogen, here there is 1 atom plus this one here. So hydrogen 2 here. So the hydrogen are balanced. Let's check for Cl. Cl, there is 1 here and also 1 here. So Cl is balanced. Cl is also balanced. Let's check for potassium. Potassium, there is 1 here and also 1 here. What else? Oxygen, there is 1 here and also 1 here. So our equation is balanced. So the concept that I want you to understand is, whenever you get an acid react with a metal hydroxide, which is a base, you get salt and water as products. Now we move on to the last part, where we are going to look at the acids reacts with metal carbonate to form salt, water and carbon dioxide. So that is our last chemical property. So acid plus metal carbonate. So the products, the first one, salt plus water plus carbon dioxide. Then we are going to use the acid, sulfuric acid, plus the metal carbonate. Let's use calcium carbonate. So the salt, we said always write the name of the metal. So calcium. So from the sulfuric we get sulfate, so this becomes calcium sulfate plus water plus CO2, carbon dioxide. So in chemical symbols, sulfuric is H2SO4 aqueous, plus calcium carbonate is CaCO3 solid. So calcium has a valence of 2, carbonate also 2, so we can just cancel this part here. So we're going to have calcium sulfate, so calcium sulfate equals plus, then we are going to now get water. Let me just get rid of this. So we are going to have water plus carbon dioxide. Now let's look at this equation. Let's begin with hydrogen. So 2 atoms of hydrogen. 2 atoms of hydrogen. So hydrogen is balanced. Sulfur, 1 here, 1 here. Oxygen, 4 plus 3, 7. Let's check from here. 4, 5 plus 2, 7. So oxygen is balanced. Then what else? Calcium. There is 1 here. Also 1 here. So we can see that our equation is balanced, because even if we look at carbon, there is 1 here, and also carbon 1 from this side. So these are the 4 chemical properties that I would like you guys to make sure you commit to memory. So please, if you have not subscribed, please do so, because your subscription gives us hope and energy to make more of this. And also like the video, comment. I need to hear from you guys. Then for all our tuitions, as usual, feel free to comment in the comment section below. So that's it for this video. Thanks for watching.